More than 1 million people have died in earthquakes in the last 2 decades. Seismic rumbling between the Earth's tectonic plates put some of the world's most densely populated countries at particular risk. These plate boundaries are most apparent around the Pacific Rim. Frequent earthquakes have led to the region's nickname, the Ring of Fire. Yet for the most part, earthquakes themselves don't pose the greatest risk. Collapsing buildings do. While buildings are generally designed to withstand vertical loads, the weight of their contents and inhabitants, they've not traditionally been built to withstand the side-to-side swaying that a tremor can bring. It's possible to design buildings so they're more resilient to earthquakes, keeping them light and flexible so that they can absorb and distribute the energy of their movement. Start with the roof, which should be the structure's lightest part. In the 1995 Hanshin earthquake in Japan and the recent quakes in Nepal, much of the damage was among top-heavy tiled roofs. In 2008, a magnitude 8 quake in the Chinese province of Sichuan took more than 80,000 lives, and engineers found tile-clad buildings largely to blame. Using materials that can bend without breaking helps make buildings more shock-absorbent. This building has steel embedded in its frame. It's being put through its paces on what is known as a shake table at the Hyogo Earthquake Engineering Research Center in Japan. Tests like these show how a building's frame is also important. Light walls and partitions and thin concrete floors can help. So can what are called shear walls, a system of panels and braces that effectively channel a side-to-side force downward into the building's foundations. The giant concrete columns at the center of modern skyscrapers do exactly that. There's also a bit of simple physics known to the architects of ancient Japanese pagodas. These were built with a giant central pole called a shinbashira, which acted as a tremendously heavy pendulum. Seismic shuffling of the pagoda's main structure transfers into the gentle swaying of the shinbashira. Since it was built in the early 7th century, the enormous Horyuji Temple in Japan has survived dozens of big quakes. Modern builders have taken note. Taiwan's Taipei 101 and the Citicorp Center in New York use hundreds of tons of concrete or steel to do the same job. All this has the potential to make newer buildings safer. But as much of the infrastructure damage in Nepal has shown, it's also very important to apply this hard-won engineering knowledge and retrofit older buildings as well.